Today we're going to talk about periodic properties, atomic radius, ionization energy, a little bit about electron affinity and electronegativity. There are more, but these are the ones we're going to focus on. The first one I want to talk to you about is atomic radius. It is exactly what it sounds like. It is the size of an atom, and it's defined as half the distance between two nuclei of adjacent atoms. The reason that they talk about it like this is because they really only like to talk about the atom's radius when they're in bonds with other atoms. Because of the way the electron cloud is, things happen when atoms are by themselves, which is, of course, very rare. Across a row on the periodic table, atomic radius decreases. Now, the reason I have here is because this doesn't actually sound like what should happen, because you would think as you move across the row, as you move, from lithium over to chlorine, as you move across the row, you would think atoms get bigger. They get more protons, so you would think the atoms get bigger, but that's not actually what happens. There are more particles, more neutrons, more protons across the row. Why do the atoms get smaller? Well, the nucleus has more protons. It actually has more electrons too, but they're being added to the same energy level. And we just got done talking about electrons and how they exist in clouds. So that cloud actually gets pulled in tighter. If you have, 4 protons, and then you have your cloud of electrons, whatever that might look like, around those 4 protons. These protons are, of course, positive, and the cloud is negative. So the positive charge pulls the negative charge. If you were to add more protons, and that cloud were to stay exactly the same energy level, this positive charge would be greater and therefore pull it in tighter. This is really important to understand because if you can understand this one concept, it really makes everything else for periodic properties make sense. Now, down a family or down a group, exactly what happens is what you would expect happens. The atomic radius increases as we go down the periodic table. Electrons are filled into higher and higher energy levels. And I think the Bohr models, even though they're not really correct, help to visualize that. The inner electrons right here, so if you have your nucleus in the center of the atom and the nucleus is positive, these inner electrons help to shield the outer electrons. All right, and shielding just means that they get in the way of that positive pull of that charge. So they're shielding these outside electrons so they're not held as tightly. And this is another reason why atomic radius will increase. Here's a really good visual. Honestly, if you just go back to this visual every single time, if you take a mental picture in your head, as you move across, you can see things get, generally speaking, smaller. And as you move down, things get, generally speaking, larger. Now, you might be wondering where are the transition metals? Well, funky stuff happens in there. So when we talk about periodic trends, we often are only talking about the main group elements. So again, as you go across, there are more protons in the center of the atom, which pulls the cloud in tighter. As you go down, there are more energy levels added, so the cloud gets larger. And again, there are more protons added too. That might be a question of yours, but it doesn't matter. The fact that there are higher energy levels kind of negates that. All right, the second thing we're going to talk about is ionization energy. Ionization energy has the word ion in it. It is the amount of energy required to remove the outermost electron in an atom. In other words, it's the amount of energy required to make an ion. Removing an electron is making an ion. Now, I know that adding an electron is also making an ion, but in this case, we're talking about electron removal. As you go across the row, ionization energy increases. This is the opposite of radius. And the reason that it's the opposite of radius is because radius has exactly to do with it. As the radius gets smaller, the electrons are held more tightly by the nucleus. We just talked about how more protons will draw the cloud in more, and therefore more energy is required to pull one electron off. And that might be cut off. And I have this silly picture here of these actors and their heights. And again, it has to do with the positive charge of the nucleus actually getting larger because you're adding more protons. And there's still the same amount of energy level, and it's kind of getting held more tightly. So this is the exact same trend or the same reason for it. It just kind of moves opposite. So you might be expecting this next one. As you move down the family, ionization energy decreases. This is this shielding effect again. So you have the nucleus, and as you move down, there are more and more and more uh, electrons added. Now I say meet mama nucleus. I like this because if you think of the nucleus as like a mom, and you think of all the electrons as these mama's kids, as you go down, you add more and more and more kids. And if Mama Nucleus has more and more and more kids to watch after, sometimes that last kid can get loose without Mama Nucleus knowing about it, right? Because these other kids are shielding that positive charge. Uh, Electron affinity, we don't really talk about. It's actually the same exact trend as ionization energy, but this is just the energy change when an atom gains an electron. Just know the definition for now. If you get to AP, you'll go into more detail about this. Now, electronegativity. Electronegativity is defined as a tendency to pull electrons towards itself in a bond. So a key part of this is that in order to find out the electronegativity of something, you need to have a bond. So we're going to see on the periodic table how some things don't even have an electronegativity. So the tendency to pull electrons towards yourself when you're in a bond is very similar to the electronegativity. It's the pull of the nucleus, how much that nucleus is pulling electrons towards it. Bigger nucleus, the electrons are getting pulled towards it more. So you can probably predict what's going to happen if we move across a row. Same thing for down a row, all right? As we move across a row, electronegativity increases. Now you'll notice these numbers here that they use for electronegativity. They don't actually have a unit, it's a relative scale. It's very important to know these numbers when you get further on in chemistry and organic chemistry and make the students memorize these numbers because they tell us a really interesting story about atoms. They tell us that fluorine is really pulling electrons towards it as compared to maybe carbon, who's not pulling electrons towards it as much. All right, so as you move across, the electrons are being pulled closer to the nucleus. And again, that's because there's more protons and the nucleus is shrinking and the cloud is getting closer. As you move down, you're going to see electronegativity decreases. Now you might be noticing over here, where are the noble gases? Well, remember I said if it's not involved in bonding, you can't have an electronegativity. Now the noble gases, or group 18 of the periodic table, doesn't have bonding happen very often because they have a full electron shell. All right, so again, down the family, electronegativity decreases. Now, I'm going to add this very important word. It generally decreases. None of these trends are foolproof, okay? You might see small, you know, things happen within the rows that don't follow the pattern, and that's okay. Here in the transition metals, there's a lot of strange stuff that happens. But generally speaking, this shielding effect is going to decrease the attractions for electrons, and therefore electronegativity will go down. The last thing I want to mention is ionic size. When atoms form cations, that's the name of a positive ion, they lose electrons. When you lose electrons, the size gets smaller. It's pretty obvious as to what's going to happen. So if you have neutral sodium, when you lose an electron, the atom is going to get smaller. So sodium has 11 protons, 11 electrons. When you lose the electron, the atom gets smaller. Remember, this is all in a cloud. You might just be thinking, well, it loses an electron, of course it gets smaller. Well, electrons don't really have much of a mass at all, but this cloud now has less charge than that center, so it's going to pull that whole thing in. The opposite is true. When atoms form anions, they gain electrons and their size gets larger. So chlorine with 17 protons, when it gains an electron, it does get bigger. Now you can look back at everything we did and practice. Like I said before, the most important chart in all of this is this one right here. If you can look at this chart, you can see atoms get smaller as you go across, atoms get bigger as you go down. If you're getting smaller, that means that the nucleus is holding on to its electrons tighter. If you're getting larger, it means that the nucleus does not have as hard of a pull on the electrons.